Okay, so what we're going to take a look at is the difference between something that is linear and not linear. Also, what we're going to take a look at is how to graph linear equations in a longer method as well as a shorter method. And we're also going to take a look at the thing that truly makes something linear, the slope. So first of all, we're going to look at y equals x squared. One of the longer methods for graphing is to make what we call a table of values. The table of values is there to help us find points to plot on the coordinate plane. Typically, the values that most teachers tell you to plug in are -2, 1, 0, 1, and 2. Those values are really good values to remember anytime you need to make a graph from an equation. But there are some weird things about some of the functions that we'll look at this year, some characteristics where we may need to change the numbers that we plug in. So for today, though, we're going to focus in on using these simple numbers. When we say we're plugging these numbers in, what we mean is we are literally substituting those values in for x, and we are doing the math and finding a y value. We call this evaluating a function or evaluating an expression. So when you plug these in, make sure you use parentheses, especially when you are plugging something in for this x here that is being squared. -2 squared actually is -2 times -2, which is 4. Then you'll get -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Right here is the key, because when you plug in -2 squared in your calculator without the parentheses, it will give you the wrong answer for these two. Notice that there is a pattern to this. It is not a very consistent pattern, but as we go through the year, we will learn that it does have a special pattern to it. You can see the pattern, but you can see that this one goes down 3, down 1, up 3. That's not the same as what we would consider a linear function. To plot these points, you go -2, 4, which would be left 2 and up 4 spaces, -1, 1, 0, 0, 1, 1, and 2, 4. Remember that this horizontal axis is like a number line with the negatives this way, positives this way, but it's the x values. The vertical axis is also a number line with the negatives and the positives, but it is the y values. Once you've got this, you can connect your dots, and this one does make a curve. It is not a line. Hopefully you can see that very obviously. We also can look at this equation and tell it is not linear. We can look at this table and tell that it's not linear. So we can look at the equation, the table, and the graph and tell that this is not a linear function. Over here, we have y equals 4x plus 2. This one actually is a linear function. And we can tell that because what's going to happen in the table and on the graph. But we can also tell it by looking at the equation, and we'll talk about that in a little bit more detail here in a second. Even though I know some of you are looking at it and saying, oh yeah, that's y equals mx plus b. That's great, and I'm glad you remember that, but I don't want you to forget that it's not y equals mx plus b that makes it linear. It's specifically what's going on in the equation. We'll talk about it. So when you plug into this one, 4 times -2, you get -8, plus 2, that's -6. 4 times -1 is -4, plus 2 is -2. 4 times 0 is 0, 0 plus 2 is 2. The next one's going to be 6, the next one's going to be 10, and I can get those really quickly because every single one of these is going up by 4, up by 4, up by 4, up by 4. And the reason I know that is because it goes to the thing that really, truly makes something linear, is something called the slope. And we're going to talk about that in a lot more detail here in a few slides. But notice that it is going up 4 and then it is going over one space from here to here. Up 4 over 1. You've probably heard that as rise over run. Guys, that is what slope really is. So when you graph these points, -2, -6, -1, -2, 0, 2, 1, 6, and 2, 10, you should be able to now physically see, not just in the table, not just in the equation, which we're going to talk about in more detail, but the actual line itself. You can see that it is linear. So when we talk about linear equations, they obviously make a line, not a curve. But there's a couple of other things. Look at the table. It has that slope, that constant pattern or constant rate of change that we talk about. And then it has an equation that is very different from this equation. Specifically, and if you want to copy this, you'll need to pause it because I'm not going to stay on this screen forever. Specifically, the variables in a linear equation are raised to the first power. They have an exponent of 1. There are also no variables inside a square root, which is actually called a radical. By the way, we'll get to that later in the year. That's called a radical function. It's not that it's not a function. It is a function. It's just not linear. You also will see that sometimes we'll get a variable in the denominator of a fraction, like 3 over x. That is not linear, but this is still a function. And when we talk about this later in the year, we call this a rational function. And then you'll also see that right here it says there's no variables inside an absolute value. Again, it's not the absolute value that's the problem. That is still a function. Sorry about that. That is still a function. It's an absolute value function. It's just not going to be linear. The key thing with linear, again, is in the word. It's a line. So it is very simple. It's an equation that has variables raised to the first power, not x squared, and there are no variables in a radical, there are no variables in the denominator of a fraction, and there are no variables in the absolute value. The key thing that makes something linear also is the table. We notice the pattern. That very strict pattern is something that shows up in a lot of real life situations as well. It's called the slope. Now, during class, I talked about the slope and how it ties to a bunch of real life situations. We'll actually do some examples of that here in just a minute. But the slope of a line is the rise over the run, the change in the y, the change in x. But you can also look at things like change in dollars and change in hours, and that would give you dollars per hour. Classic example of the slope in your life would be if you have a job and you make dollars per hour. When we are looking at a line or a real life situation and we want to find how two things are changing compared to each other, we do have to be able to use subtraction, because subtraction is how you find the change in two numbers. If you want to find the change in temperature from the morning to the afternoon, you have to subtract the afternoon minus the morning, and it will give you the change in temperature. So change in y is y2 minus y1. Change in x is x2 minus x1. Be aware that you may also see this little thing. It looks like a little triangle. It's actually a Greek letter delta, delta y, delta x. That still means the same thing. Change in y over change in x. Now in class, we did all 4 of these problems on the slope. I'm not going to go through every single one of these on this page because I have a few other review problems. But I do want to reiterate the formula, so I'm going to practice one of these with you. 2 minus 4 over 9 minus 3. y2 minus y1 over x2 minus x1. Please make sure that you do the change in y's on the top and change in x on the bottom. That's also very critical when you're talking about real world situations. Make sure the appropriate numbers are on the top and the bottom. 2 minus 4 is negative 2. 9 minus 3 is 6. So this fraction reduces to negative 1/3, and you can use your calculator to help you do that if you need to, but it is down 1 over 3. The negative or positive tells me if the line is rising or falling. Some lines can go up from left to right, and some lines can go down from left to right. Also, make sure you understand that it doesn't matter if you do the other way around. If you subtract 4 minus 2 and 3 minus 9, if you switch the points around, as long as you do the change in y's on the top and the change in x's on the bottom, you still will get the same answer for your slope. The slope tells me the steepness of the line, so you also look at the number to help tell if the line is a very steep line or not so steep. And you can also tell if a line is going to be horizontal, if it has a 0 for the slope, or vertical if it is undefined. Now, what undefined would look like would be these 2 points right here. If you found the slope of these two, you would do 5 minus negative 1 over 2 minus 2, y2 minus y1 over x2 minus x1, and you end up with 6 over 0. You cannot divide by 0. That is what we would call an undefined slope. Some teachers will call this no slope. I personally don't like that, only because it kind of gets confusing with 0. So I like to remember that 0 is flat. It's horizontal. It'll have a 0 on top of the fraction. Undefined is when you have a 0 on the bottom, because you cannot divide by 0. So, in class, we also mentioned these. We mentioned parallel and perpendicular. Key thing here is to know that lines are parallel if and only if their slopes are the same. Perpendicular lines, remember, intersect at a right angle, and lines are only perpendicular if and only if their slopes are opposite and reciprocals of each other. So if you look at the first example down here, line number 1 is these 2 points, line number 2 is these 2 points, and it says tell whether they're parallel, perpendicular, or neither. Guys, this is an option. Don't forget this. Lines do not have to be parallel. Lines do not have to be perpendicular. They can just touch each other somewhere, and that's okay. So when we find the slope here, you do negative 1 minus 3 over 3 minus negative 3. Again, I am doing the y2 minus y1, x2 minus x1. It gives me negative 4 over 6, which reduces to negative 2/3. The second line here, I'm going to do 3 minus negative 3 over 2 minus negative 2. That is y2 minus y1 over x2 minus x1, and that gives me 6 over 4. 6 over 4 reduces to 3/2. Are these two the same? No, so they're not parallel. Are these two opposite and reciprocal? Yes. This one is negative. This one is positive. This one is 2/3. This one is 3/2. Or 2 over 3, 3 over 2. That means they are opposite and reciprocal. So these two lines right here are what we would call perpendicular. Now, if you found the slope between these over here, you would find out they are neither. They are not parallel. They are not perpendicular. So, it doesn't have to be one of these. These are just a couple of special types of lines you might run into. You saw these in geometry, but you can also see these in algebra as well, dealing with parallel and perpendicular lines. We'll come back to this concept again in the next section on the next day that you see me. So, we also have this concept of real life slope, or in other words, what other people would call the rate of change. In real life, not a lot of people use the word slope like we do in math class, but you still use the concept of slope to explain things that are changing at a constant rate. And specifically, it's two things that you are comparing. For instance, I have this example here that it says you are parachuting. At time 0 seconds, you open your parachute. at a height of 2,500 feet above the ground. At time 35 seconds, you are at a height of 2,115 feet. Both things are changing. The time is changing and the height is changing. And so when you look at this, if you want to know your rate of change, you are comparing the height and the time change to each other. Think logically here. If you're telling somebody that you're falling through the air, you're parachuting, you are going to use the units feet per second. I know that because I'm talking about feet, I'm talking about seconds. I also know that because it doesn't make sense to say seconds per foot. That is really not appropriate. If you told somebody that you were falling at 11 seconds per foot, they would laugh at you. So when we talk about this, we're talking about something that is logical. Feet per second is how you would tell somebody you're falling. Then you treat the rest of this just like the slope. The slope is a way to represent the rate of change. So what you can do is the same thing you did before. You can do y2, which is 2,500 feet, minus y1. Sorry, let me rephrase that a little bit. I like doing it in the correct order here, or the way that it makes sense to me. Y2, 2,115 feet, minus 2,500 feet. The second feet value minus the first. And the reason I like that is because it lets me know that I'm actually falling here because it's negative 385, which is exactly what we would expect if you're parachuting. On the bottom, you have feet per second. So on the bottom, you're going to put your seconds. 35 seconds for that measurement and 0 seconds at the beginning. Now, this is a pretty easy one, 35 minus 0. The change in time has been 35 seconds. So you have the change in feet, the change in time, but it's going to give you feet per second as a measurement. If you divide this, you'll actually see that it is negative 11 feet per second. And it's okay to divide that out, and it would be okay to even use a decimal on this one if you were explaining it to somebody compared to a fraction. You don't need to use fractions all the time when you're dealing with a slope. Only when it makes sense to use the fraction for your rise over run, or use a decimal or whole number when it's talking about something like parachuting. So the final thing that we talked about in class the other day, and I'm going to review with you, is graphing lines very quickly. Instead of having to go through and make a table of values, you can use a couple of special points, or you can use the slope-intercept form. The special points that we talked about the other day were the x-intercept and the y-intercept. Remember, the x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. For the x-intercept, on the x-axis, the y value is always 0. So what we do is we actually plug in 0 for the y value. When we do that, that cancels out 3 times 0, but it leaves us with a small equation, 2x equals 6, which is extremely easy to solve, or should be. And you divide by 2 to get 3. Remember, I also told you in class, I'm going to reiterate that here, you need to make sure that you actually write this as an ordered pair for 3 in your x value and y is 0. Because I want you to know that is specifically a separate point on the graph from your y-intercept. It is not the same point. It is a completely separate point. Remember, the whole point with graphing using this method is that you get 2 points, because that's what you need to make a line. The other intercept, the y-intercept, is on the y-axis. The x value is always 0 on the y-axis. That's just what the x value is there because you're right in the middle of the graph. So what we do is we actually plug in 0 for x this time. Again, we're finding a completely separate point. So we go back to our equation and we plug in 0 we're going to end up with this canceling out, leaving me with 3y equals 6. I divide by 3, y is equal to 2. Again, a totally separate point. So 0 is x, 2 is y, and then I have a totally separate point to plot. That's why we're doing this, because now, if you look, you've got 2 points to connect the dots and make a line. So, remember that these points are on the line when you're finding them. Remember also that they are solutions to the equation, so you can plug this in and it should work. The other thing that you should know, and we're going to look at this all year long, is that if you do plug in a number for y, or you do plug in a number for x and find another value, that's always going to be a point on the line. That is just a handy skill to have when you are dealing with equations. If you know one number, you can find another number. So we graph this line across here, and now what we have is we have a huge set of points. Every single point on this line, you've got a point here, you've got a point here. Every single point on this line is a solution to this equation. That's the reason that we graph. So, take a look at another quick example right here. To save a bit of time, I'm going to plug in real quick here 0 for y to find my x-intercept. If you divide by 3.5, you're going to get x is equal to 4. That means 4, 0 would be my x-intercept. Then I plug in 0 for x to get my y-intercept. You end up with 7y equals 14. Divide by 7, you get 2. 0, 2 would be my y-intercept. Again, giving you a line that now you could use if you needed to find more points, which are solutions to this equation. Next time in class, we're going to take a look at this example right here to go through and show you how you can use that to help you with something in the real world. If you want to snap a quick picture of this or pause and try to do it, we're going to take a look at it and you can see if you got it right next time in class. I also want to point out that when you're finding the intercepts of the graph, like the x-intercept or the y-intercept we were talking about before, when you do the x-intercept on this one, you plug in 0 for y. Be careful because you're going to get 0 equals 4x plus 40. Do not tell me that it's 10. You have to subtract that 40 first. It's actually going to be negative 40 equals 4x, and divide by 4, you get negative 10, not positive 10. So make sure you're careful when your equation is a little different. Also, when you're finding the y-intercept on this one, don't overthink it. X is equal to 0, so that means you're going to plug in 0 for x. 4 times 0 plus 40, that means the y-intercept is 40. It is actually that easy on that one. So your y-intercept is at 0, 40. So to tie this into the last thing that we're going to talk about, why in the world is this 0, 40? Why is this the y-intercept? Because if you remember back to Algebra 1, this y equals 4x plus 40, like that one you talked about earlier, the 4x plus 2, is in what we call that slope-intercept form, or y equals mx plus b. So how does that help us when it comes to graphing? If I've got y equals mx plus b, this is called the slope-intercept form. Think about it. Why would it be called that? Let's Just logically go through this. The slope is part of the problem, just like we used m to represent slope a little while ago. The intercept here is also part of the problem. The tricky part, yes, is remembering that the m is the slope, even though technically you've done that enough, you should know that. Remember, we talked about that being the rise over run. And remembering that the b here is the y-intercept, not the x-intercept. It's the y-intercept. So it's going to be 0, comma, whatever the b value is. And it's always going to be located on the y-axis. How does this help us when it comes to graphing? It helps us because you can always start with this point because you know it's going to be on this axis. And then you can use this point, rise over run, to find another point. Because if you know one point and you know the slope, you know from one point to the next point, it will follow the slope. That is what a linear equation always does. So when we look at this slope-intercept form, it helps me really quickly graph a linear equation. Let's go back to that example that we looked at the very beginning of class here. 4x plus 2. Where is the y-intercept? At 2. Look at where it crosses the y-axis. At 2. What's my slope? 4. Up 4 over 1. So if you go up 4 over 1, you can see that this graph does that all the way across here, and you could follow those little stair steps to make an entire line. You only need 2 points to make the line, so you don't have to do it a bunch of times. So this right here is a really easy way, quick way to graph problems when it is in this form, slope-intercept form. So take a look at this one. The slope is 2, or 2 over 1 if you think about your rise over run. Then we see that the y-intercept right here is 1. So the y-intercept is 0, 1. So your b value is 1. If you look at that, what you can do is you can start your graph at 0, 1. You know your graph is going to touch that point. Then you know your graph is going to do 2 over 1. So you go up 2 over 1, up 2 over 1. Remember, slope is always measured from left to right. So make sure that if your line is positive, it should be sloping up from left to right. What I also do for my students is I also try to give you sort of a goofy way to remember this, and it helps you with word problems with these. So my goofy way of remembering this is noticing that it's mx plus b and saying, okay, my m is 3 over 2, my b is 2. So that means I'm going to begin the graph at 2, and then I'm going to move up 3 over 2, and then I connect my dots, and I've got my line. Now, obviously, hopefully you can draw a little bit straighter line than Mr. Harrison can, and that's probably the case with Mr. Harrison's drawing, right? But you can do this with any equation that fits that format. Even if it doesn't fit the format, if it looks like this guy right here, you can still get y by itself by adding 6x to both sides. That would be 6x plus 9, or you could put 9 plus 6x. And dividing both sides by 3, that gives me y equals 6 divided by 3 is 2x. 9 divided by 3 is 3. So then you begin at 3, and then you move up 2 over 1. Then you connect your dots, you got a line. Wow, let's stop doing that, Mr. Harrison. Let's go through and actually draw a line, right? Now, the whole point, and yes, the pun is intended, is that every single point on this line, up 2 over 1, up 2 over 1, up 2 over 1, every single one of those points is a solution to that equation over here. So don't forget that. Don't forget that the reason we are graphing ultimately is that it gives me x values and y values, to plug in that actually are solutions to make it equal 9. And you can also do this with negative slopes. I know the examples that I looked at just now all had positive slopes, but you can do it with negative slopes as well. The last thing I'm going to give you is just a little helpful reminder about these two special kind of lines, like y equals 2 and x equals negative 3. Anytime you see y equals a number, that one is a horizontal line. So anytime it is y equals a number, it is always going to be a horizontal line. So for instance, if it was like this guy right here, and that was 3 spaces up, it would be y equals 3. The reason is because there's no slope. There's no m, right? So that means the slope is actually 0. It's not undefined. It's a 0x plus 3. You don't need the x, though. You don't have to put 0x. So it just means you have counted up 3 spaces and put a 0 sloped line. Vertical lines, like x equals negative 3, when it's only an x, that is a vertical line. That is when you have x equals some number. We'll use this example right here. This would be x equals negative 2. That would mean that x is negative 2 all the way up and down. Guys, one way to think about both of these is to look at what it literally says. This one says y equals 3, and that means y is 3 always. So if you look at this graph right here, every single point on this line, y is equal to 3. Same thing with a vertical line, x is equal to negative 2 means x is always negative 2. So really, when you see these lines, please don't overthink it. All you have to do is go, oh, okay, y equals 2. That means y is 2 the whole time. So I'm going to go to y equals 2, and I'm going to draw a line straight across the graph because it's always going to be y equals 2. X equals negative 3 means x is negative 3 the whole time. So I'm going to go to x is equal to negative 3, and I'm going to put a line, sorry, I'm going to have to watch out for my little box down there, at y equals negative 3 the whole time. So those two types of lines are extremely easy to graph. Those are probably the easiest lines you ever graph because they are just horizontal and vertical. You just got to be able to count, remember which one's which. So what we've done is we've looked at a bunch of different linear things in this video. This video will be great to come back to over and over again if you need to give yourself a little refresher on linear equations numerous times throughout the year, because we will continue to use linear equations all throughout the year. So if you need any help or anything, let me know. If you need some extra help, come back and see me. Hope you enjoyed the video and hope you can use it.